Hello all, here's today's item of interest. This is a trash pile special. It's a Corsair H60 self-contained water cooling system for a computer. I picked it up out of the rubbish pile. I don't think it works. Honestly, I don't really care. I'm not really interested in water cooling my computer. I'm running an i7, and honestly the stock heatsink's fine because I don't overclock. It's kind of interesting. One of the things that I've noticed is, it runs off 12 volts with your fan header, but it's actually got what looks to be a 2-pin header right here, and I don't know what that's for, and it's not mentioned in the manual, so maybe that's like for debugging or something along those lines. Obviously it's got a beeper, presumably to let you know when the pump inside of it has stopped working. Generic hold down, it uses brackets that, you replace the default, clamping bracket, I believe. Plastic lid. Anyways, let's just take a look and see what's inside. I kind of want to see what the pump is, which is why I'm taking it apart. Oh, there we go. So here we are. So you can see, okay. So right here, this looks a lot like a thermistor. And you can see that that's connected there, and that appears to be going into the processor, or onto the metallic portion of it. So I'm betting that these are for like an on-metal temperature measurement mechanism. Here's the actual pump, and you can see that there only appear to be 2 leads running to the rotor internally, which means that even though it's electrically commutated, it's not particularly, it's not like really aggressively electrically commutated or anything, because it's only one phase. So at best they're driving this with like an H-bridge layout, and therefore, at most it's a 2-phase brushless motor, because they drive it each way. These are interesting. You can see these are 0 ohm resistors, so they're just using those as jumpers. Ground, VCC, and FG, which is effectively the it just tells you whether it's the tachometer output. There's a big diode. That's a Hall effect sensor right there. You don't see anything else in those 4-lead packages. Yeah. So what I am going to try to do, that actually may not be a beeper. That looks like it goes into the system and may in fact have been part of the filling system. So what I want to do is I want to figure out how to drain this without making a giant mess. Let's take the metal cover off, so I can have a paint tray here just to try and catch all the coolant in there. So this is fairly nicely designed. It looks like it's just 2 halves. Yep. Off like so. So these are nice in that they can, there's presumably little O-rings in there so they can rotate. So I kind of want to see, because one of the things they do on some of these pumps is, because they're brushless, is they basically, the magnet is in direct contact with the working fluid, in this case presumably water and antifreeze, and so they effectively, the coils are sealed, but the magnet just sits in the fluid, so therefore they don't need any sort of seal, any seal on a rotating shaft like they do in traditional pumps. So the end result is that you can have like an extraordinarily long working life, because everything in contact with the fluid doesn't need any sealing. So they can use open bearings, and then maybe mix some oil in with whatever the coolant is, and then they're lubricated by that, and at the same time they can totally pot all of the electronics, and there's no, basically seals that have to endure motion. So anyways, it does appear that this thing that I initially took to be a piezo beeper goes right into the fluid system, which means that it's presumably part of a filling mechanism of some sort. So I am going to shove something in there and presumably get whatever the coolant is all over my pants. Let's see. Okay, that's actually hard. Okay, so that. Try something slightly thicker. I don't want to break my hex key set. It appears that this is a cap of some sort. I wonder, I mean, presumably they had to have filled this somehow. Yeah, see, that was what I wanted to avoid. Bother. Well, I mean, these are kind of cheap hex keys, so what do you expect? Let's go up one size further. Kind of opening the hole up over time. Oh yeah. I mean, I could just take the screws out and then just try and capture the fluid, but I'd rather try and drain it a little more elegantly. Of course, not that I'm likely to manage to do anything elegantly, but we shall see. Right. This appears to be free to rotate to some extent. Let's see, yep. So, presumably more O-rings. Oh, I see what's going on. So one of the things I noticed is that if you look here, you can see there's little dowel pins, or cotter pins, that are holding these in, and I bet that's what that is. So it looks like that's not going to be much. I don't think I'm going to have much luck there. Let's see if I can't just... Alright, time to make a mess. So these are just... Is it leaking a little bit? It smells like... Yeah. Well, holy shit, it was under pressure. And it made a mess of the camera. And it smells like antifreeze. That was interesting. Also, it appears to have had a fair amount of gas in there, which is kind of strange. It's got gook everywhere. So, let's see. So, of course, it's probably vacuum locked, so let's open the other. Ah, there it goes. Now it's doing nice caustic green color. Presumably most of the fluids in the radiator you have effectively reservoir here and here. And the radiator's largely uninteresting anyways. Just because it's basically just a box. Ugh. It smells rather intriguing. Ugh, it's all sticky. There we are. It's just kind of draining the fluid. Ugh. A fair amount of fluid in there. That's probably not the total extent of it either. Oh yeah. Alrighty. Probably just soak it up with paper towels and throw it in the garbage bin eventually. So that would be that. Now, I think I will cut off the hoses. Just appear to be, feels kind of like ABS hoses, I think. It's hard plastic. It smells like engine coolant, so it's presumably got polyethylene glycol or whatever that stuff they put in. Good old antifreezes. Yuck. My hands are sticky. Smells wonderful. So it's possible that the entire mechanism is sealed, and just by removing the motor section, this may not even, release into the interior of the pump. We'll have to see. This is kind of why I want to take it apart. I'll also eventually I want to see what the mechanism is in there. There may be like fins or something internally. One thing of note is that this is fairly well engineered, because you can see these are machine thread screws and there are brass inserts in there. So it's not, whoever engineered this did indeed care to some extent in any event. Okay, so that's directly exposed to the fluid, and there is the pump rotor. So presumably, okay. So that's actually quite interesting. So the way this would work is the fluid would enter through here, and then the veins would effectively, this would throw it out and centripetally, and then there is a exit right down here. So I would guess that the fluid comes in through this, runs into here, comes up, flows down into the water block mechanism, that's the actual thermal contact, through this little orifice down here, flows past the processor, and then runs to the reservoir. So let's just mop up this little bit of fluid. Because I do kind of expect this to make a mess in a moment. I could try and get as much of the fluid out of there as possible before I open it up, and then proceed to spill the rest all over my workbench. So one thing we can do right now is push on these pins. So by basically just applying force that way. Okay, yeah, this is just leaking everywhere, and I'm making a mess. I have to get more paper towels in a minute. Imagine the stuff is not bad enough that I have to worry about just coming in contact with it, but what do I know? Ugh, it's dripping everywhere. Let's see which of these is the right size. That one would appear to be it. Maybe a little bit small, I think. Anyways, let us take a look down here. Is this the right size? Yes, it is. Excellent. The whole thing is fairly well engineered. I would imagine that given you're designing a system that's going in people's computer, and if it ruptures and leaks, yeah, somebody's going to sue you. So they put a fair amount of care into making it well engineered. Oh yeah. It's actually a little small. This may in fact be using metric. Yep. Well, I think it's, yeah, so these are apparently 1.5 millimeter. Yep. Alright, so now that should be free. So if we go like that, well, have a look at that. So there's the actual contact section, and you can see they have some really amazingly fine fins on here. You can look at the pitch on those, and you can also see that it appears there's some goo stuck on it, which may explain why it was thrown away. It looks like maybe there's some sort of electrochemical corrosion. Normally one of the issues in loops like this is because this is copper and the radiators are normally made of aluminum. You get electrochemical corrosion, and normally they have to put inhibitors and stuff in the coolant, but I wonder if they didn't. So you can see that the fluid enters through this section here, and then effectively it gets forced into the slot in the center and flows out to each side. So what happens is the coolant enters here, flows through. This is like a compliant, so this is basically just kind of a sealant gasket. Exits through here, and then the exit from the system is right through this little hole right here. So I should be able to, yep. So you can see just the kind of insane fineness. And I wonder how they machine this. Let's see if on the sides it wants to focus. I mean, I wonder how they even machine such just ridiculously fine fins. They're not very deep. I wonder, it's probably like a horizontal machining operation. But my lord, the cutter for that must break very easily. And I should be able to kind of flex very easily. But you can see how there's like this row of gunk clogging it up, which presumably reduced the loop efficiency. So anyways, there's a, you can see that it looks like they used just a straight up 1/8 inch end mill to machine these two trenches here, which are largely for the fluid outflow. And then this is basically, yeah, you can actually see here's the thermistor that pokes through. So what that happens is that just winds up being in physical contact with one side of this. Another thing of interest is whatever this blue goop is, this thing may have leaked, or this may have been some corrosion of some sort. I doubt it's like a sealant. There is so the O-ring just sits on here too. There's no O-ring groove. Come on, focus. So this is, I mean, it's a discolored section from the O-ring being in contact with it, but there's no actual texture there. So the extent of the O-ring is held in by basically the groove here. Anyways, it's fairly nicely made. I mean, I would just want, it looks like it might have longevity issues, you know, from the interesting corrosion going on here and some of the gunk stuck in it. But for what it is, it's surprisingly nicely engineered, actually. Let's see. Oh, that's nice. So they actually have a it's keyed. It only goes in one way. So there we go. Well, let's actually towel. So let's take a look at this pump. So you can see, oh, that's interesting, look. So if you look at the pump, you can see that there are holes cut into it. And I bet that's to allow the fluid to come in contact with the winding. So you can actually see that the windings are in the center, and then there is the magnet is right here, is along the edge. So effectively this is just plastic, and then there's a thin rim of magnet around the edges. And it cogs noticeably. I mean, I can kind of feel it cogging. Let me stick 12 volts on here and let's see what it does. There we go. I think I'm going to run into my old, don't have very long cables, and I moved my bench around. Recently issues. There's 10 volts. Should make it do something. So center is positive, and then one of these is one of them is tachometer. I don't remember which, so let's just try one. Well, that was intriguing. Let's try the other one. No. Ah, there it goes. So it looks like it works fine. It's throwing goo everywhere. So that is at 11.8 volts. It's drawing 80 milliamps. And it is moving pretty damn fast too. It doesn't fuck around. Well, there you go. Look how... That's rather interesting. Look at it try and start. So if I... So that's intriguing. So it oscillates, but if you hold the base plate steady, it doesn't. So apparently it needs a certain amount of mass to start properly. Well, it's quite a nice little pump design, to be honest. Well, there you go. So that's the interior of... There's the actual pump on a Corsair H60 water cooling system for a computer. It's interesting, you can see that this has some of the pins on this, whatever the controller in here, are bonded. So presumably those are the power device. This may in fact be only a single phase, like most fans of this, computer fans are. They just energize and de-energize it in, pulses. And then they just rely on the mass to, coast between segments. Well, there you go.